Hello students, welcome back to Future Foundation. Students, in today's class of straight lines, we will learn the concept of image of a point, and then we will see what are concurrent lines and what is the condition for concurrency. So let's begin. Students, make heading image of a point. Image of a point. So in this we will write image of a point x1 y1 with respect to the line ax plus by plus c is equal to 0. So let's say this is the given line ax plus by plus c is equal to 0, and it is a given point, say px1 y1, and we need to find image of p, say p dash. Let's say alpha and beta are the coordinates of p dash. We have to find in terms of x1 y1 and abc. Now for image we have the formula, that is L, that is alpha minus x1 by a is equal to beta minus y1 by b is equal to minus 2 times ax1 plus by1 plus c on a square plus b square. This formula we will use to find alpha and beta. So alpha minus x1 by a is equal to minus 2 times ax1 plus by1 plus c on a square plus b square, and beta minus y1 by b is equal to minus 2 times ax1 plus by1 plus c upon a square plus b square. Okay, students, for this formula we need not to prove to see its proof. Okay, make note, image of p x1 y1 with respect to first x-axis x1 comma minus y1, second about y-axis image will be minus x1 comma y1, about origin it is minus x1 comma minus y1, and fourth about y is equal to x, line y is equal to x, which is y1 comma x1. Okay, now y with respect to x-axis, these are the coordinates. Let's see. Say this is point p x1 y1, and we have to find this p dash. Say this is alpha comma beta. Now from alpha minus x1 by a is equal to beta minus y1 by b is equal to minus 2 times ax1 plus by1 plus c upon a square plus b square. Here ax plus by plus c is equal to 0 is this line y is equal to 0. So alpha minus x1 by 0 is equal to beta minus y1 by b is 1 is equal to minus 2 0 plus y1 plus 0 on 0 square plus 1 square. So alpha minus x1 upon 0 is equal to minus 2y1 upon 1. So alpha is what? X1. Well, after cross multiplying 0, it will, in RHS it will become 0. So alpha is x1 and beta minus y1 is equal to minus 2y1. So beta is equal to minus y1. Therefore p dash will be x1 comma minus y1. Similarly, we can prove for all other three cases. Now let us take a question. Okay, but before question, let us talk about foot of perpendicular also. Foot of perpendicular means if this line is, means we have to talk about this point also, say h comma k. So for foot of perpendicular we also have the formula, which is h minus, let us say this is an h comma k, the x1 y1. So h minus x1 upon a is equal to k minus y1 upon p is equal to minus a x1 plus b y1 plus c upon a square plus b square. So for foot of perpendicular, in formula of image, this 2 is not shown. In image there was 2, but in foot of perpendicular 2 is omitted. This is method 1 for foot of perpendicular. There is another way to find out foot of perpendicular. Say this is method 2, and method 2 is having some steps how we can find another way foot of perpendicular. Point number 1 is find slope of a given line. Point number 2, now find slope of line perpendicular to the given line. Then find equation of perpendicular passing through the given point, right? Point number 3, find point of intersection of lines or line and perpendicular to it, which is required foot of perpendicular, which is required foot of perpendicular. Okay, now what I'm saying, first of all we have to find slope of the given line. As line is given, we can directly say what is slope. Okay, now uh, if I want to find the slope of perpendicular, then from the concept m1 m2 is equal to minus 1, we can also say slope of perpendicular to the given line. Now I have slope of P dash or PM? Now, we can also find the equation of PM by using slope point form, because PM is passing through P, which is x1, y1, and also have slope. Now, we have equation of PM, equation of given line. Now, solving equation of PM and equation of given line, we can have point of intersection M, and which is foot of perpendicular. Okay. Now, point number fourth is for image. Also, foot of perpendicular is the midpoint of the line joining point, which is given point, and its image. Okay. So by using the midpoint formula, we can also have image of the given point, right? Now let us take an example. Question is, find foot of perpendicular and image of 1, 2 on the line 3x plus 4y plus 5 is equal to 0. Now let's say this is the equation of line 3x plus 4y plus 5 is equal to 0. This is the line, and this is point P, 1, 2. We have to find image of P dash, say alpha beta, and also we have to find the foot of perpendicular M. So first of all, we will use the formula. First, for image, alpha minus 1 by 3 is equal to beta minus 2 by 4 is equal to minus 2 times 3 into 1 plus 4 into 2 plus 5 on 3 square plus 4 square. So alpha minus 1 by 3 is equal to minus 2 times 3 plus 8 plus 5, 16 by 25. So alpha minus 1 is equal to minus 96 by 25, or alpha is equal to minus 96 plus 25 minus 71 by 25. This is alpha. And beta minus 2 by 4 is equal to minus 2 to 16 by 25. So beta minus 2 is equal to minus 128 by 25. So beta is equal to minus 78 by 25. So this is image, and foot of perpendicular is h minus 1 by 3 is equal to k minus 2 by 4 is equal to minus 2 minus times 3 into 1 plus 4 into 2 plus 5 upon 3 square plus 4 square. So h minus 1 by 3 is equal to minus 16 upon 25, or h is equal to minus 40 48 by 25 plus 1. So H is minus 23 by 25, and K minus 2 by 4 is equal to minus 16 by 25. So K is equal to minus 64 by 25 plus 2, which is minus 14 by 25. So this is by formula, or we can find photo perpendicular or image by using midpoint formula concept. So if I say H is equal to what? Alpha plus 1 by 2, alpha plus 1 by 2, and alpha is what? Minus 71 by 25 plus 1 by 2. Okay, so H is minus 46 by 25 by 2, which is minus 23 by 25, and K is beta plus 2 by 2. Beta is minus 78 by 25 plus 2 by 2, which is K is minus 10 by 25. Okay, so this was image and foot of perpendicular. Now next heading is condition for concurrency. Condition for concurrency. So in this we write, if 3 or more lines are said to be concurrent, then they will then they are passing through a common point. Through a common point. That point is called point of concurrence. That is what I am saying. Point number 1. If L3 is passing through the intersection of L1 and L2, then L1, L2 and L3 are concurrent lines. Concurrent lines. That is, say this is L1 and this is L2, and through this through the point of intersection of L1 and L2, line L3 is passing. Then we can say L1, L2, L3 are concurrent lines. Point 2, for L1, E1x plus P1y plus C1 is equal to 0. L2, E2x plus P2y plus C2 is equal to 0. L3, E3x plus E3y plus C3 is equal to 0 if A1, B1, C1, A2, B2, C2, A3, B3, C3 is equal to 0, implies L1, L2, L3 are concurrent, right? Or vice versa. Also point number 3 is, if lines P is equal to 0, Q is equal to 0 and R is equal to 0 gives P plus Q plus R is equal to 0, then P, Q, and R are concurrent lines. But converse is not true. That is, if P plus Q plus R is equal to 0, it doesn't mean that P is equal to 0, Q is equal to 0 and R is equal to 0 are concurrent lines. Okay. Now let us take some examples. Question 1 is, if x plus y is equal to 1, 2x minus y is equal to 0 and x plus 2y plus lambda is equal to 0 are concurrent lines, then find lambda. Okay. So if three lines are concurrent, then determinant corresponding to these lines is 0. That is, according to question, 1, 1 minus 1, 2 minus 1, 0, 1, 2 lambda is equal to 0, or 1 into minus lambda minus 0, minus 1 into 2 lambda minus 0 plus 1 into, minus 1 into 4 plus 1 is equal to 0, or minus lambda minus 2 lambda minus 5 is equal to 0. It means lambda is equal to minus 5 by 3. Next question is, check lines 3x plus y minus 2 is equal to 0, 2x minus y minus 3 is equal to 0, and 5x plus 2y minus 3 is equal to 0 are concurrent or not. So also there is another method for point of concurrency or concurrent lines. If third line is passing through the intersection of first two, then lines are concurrent. So say this is 1, this is 2 and this is 3. Finding point of intersection for 1 and 2, that is 3x plus y minus 2 is equal to 0 and 2x minus y minus 3 is equal to 0. 5x minus 5 is equal to 0 implies x is equal to 1. So y is equal to 2 minus 3, which is y is equal to minus 1. So if third line is passing through 1 and minus 1, so 5 into 1 plus 2 into minus 1 minus 3 is equal to 0. 5 minus 5 is equal to 0 implies 0 is equal to 0. It implies that lines L1, L2 and L3 are concurrent because point 1 comma minus 1 is satisfying third. It means line 3 is also passing through 1 and minus 1 because L3 is passing through 1 comma minus, thus N1, L2, L3 are concurrent line. Okay. Now let us take one more question. R 2x minus y minus 3 is equal to 0. X plus 2y plus 1 is equal to 0 and minus 3x minus y plus 2 is equal to 0 are concurrent or not. This is P, this is Q, and this is R. So if I add these three, P plus Q plus R implies what? 2x minus y minus 3 plus x plus 2y plus 1 plus minus 3x minus y plus 2, which is 0. So P plus Q plus R is equal to 0 implies P is equal to 0, Q is equal to 0, and R is equal to 0 are concurrent lines. But if for some values P plus Q plus R is equal to 0, then we cannot say directly that P, Q and R are concurrent lines. But in this case, P is equal to 0, Q is equal to 0 and R is equal to 0. When we sum up for all these three, we are getting P plus Q plus R is equal to 0. So in this case, lines are concurrent. So students, this was all about today's class. Let's meet in next class. Till then, bye bye and take care.